Alright guys, so this is a video on solving systems of equations with matrices using inverse matrices. If you have a square system, I wrote up here, so you have the same number of equations as you do variables, which means our coefficient matrix is going to be a square, so a 2 by 2, a 3 by 3, something like that. Then you can use either of these methods that I'm going to do in the next two videos, and the first one is to solve using inverses. So for inverses, I'm going to do a couple 2 by 2 systems. I think it makes the most sense. If it's not a square system for matrices, then Gaussian elimination, like we've done previously, is going to be the way to go. So I have our system over here, and I'm going to go through kind of a little bit on why for this one. But we can write this system as a coefficient matrix, a variable matrix, and then the answer. And what I mean by that is we can take all the coefficients like we normally do for Gaussian elimination, and then I can write the coefficient matrix, and then we have our answer matrix here. So if we actually multiply these two, I'm just going to write it out, right? 6x plus y. Actually, I think we can just see it would be equal to this first equation, equals -8, and then that -4, oops, trying to erase this guy, -4x minus 5y would be -12. So that would be equal to that system we have above. But now that we know inverse matrices, right, just like if we are multiplying, or if we were trying to solve this system, I would really divide by this matrix, right? Technically, if I could divide everything by this matrix, then I could isolate that xy equation. Unfortunately, there is no matrix division, so that's not going to work out, right? But we can multiply by any matrix. So if I call this matrix A, and I'll call this, I'll just leave it xy, equals matrix B over here, in order to isolate the variables, if I multiply by the inverse of A, then these guys will cancel. Now, matrix multiplication, the order absolutely matters. So since I'm multiplying on this side by A inverse times A, I need to keep that order the same over here. So this side needs to be A inverse times matrix B. So I'll rewrite down here x, y, and then we're going to find the inverse matrix. So equals, I don't need to multiply. To find the inverse, I can do 1 over the determinant. So 6 times -5 would be -30 minus 4 times -1 times, we flip around our matrix and take the opposite sides of the other diagonal, times our matrix B. So remember, if you need a little review of determinants, you might need to go back to our last section. But going through, so I'm going to simplify a couple of these, and notice that, right, this is kind of a rough fraction here. We get 1 over 26 for this. So I'm actually going to multiply these, right? It doesn't matter the order of multiplication now. I'm going to multiply these two matrices first, and then I'll put that 26 in at the end. So taking my time, I get -5 times 8, so 40, plus 12, with a 2 by 2 and a 2 by 1. So this guy's going to be 2 by 1, which makes sense, right, our variables. And then I have 4 times -8, which is -32, minus 72. So once we simplify all the way here, I will have 1 over 26 times, it looks like 52 over -104. And these actually work out pretty nice to 2 and -4. So that would be the solution to this equation. X equals 2, y equals -4. And remember to check, you can always sub these back into any equation for original system. So that's going to be my answer there. All right, so I'm going to do one more example here if you guys need one more to try out. Otherwise, maybe I'll just write it in try it and see how it works. Otherwise, there are some examples for your homework, right, your practice for today to try out. So one more example, solving a 2x2 system with inverses. And I'm going to go a little bit faster on this one. So I'm just going to jump right to this second. Well, I'll write out what our system would be. So to solve this, we would get my answer matrix would be A inverse. So 1 over -3 plus 8. Mix up my matrix times my constants, those answers. So we'll get 1/5 here. We'll have -6 plus 26. 24 minus 39. 20, and down the bottom I'll get -15, I think. Hopefully I'm looking pretty good. And if all is well, then my answer should be 4 and -3. Let's see a quick check on this guy. I'll get 12 minus 6 equals 6. Looks like we're doing great. So that would be the answer to this system. So that's their solving using inverse matrices. Since we only did inverses of 2x2s, this is really what we would use for that. But otherwise, for 3x3s, I'm going to do Cramer's rule next. And good luck on these.